Have you ever stopped to wonder how your phone, your laptop, your TV, and maybe a dozen other gadgets can all be online at the same time using just one internet connection? Well, the answer is a really clever bit of networking magic called network address translation, or NAT for short. And in this explainer, we're going to pull back the curtain and demystify exactly how it all works.
To really wrap our heads around this, we're going to break it down into three simple parts. First up, we'll get to know the two kinds of addresses that make all this possible. Then, we'll actually watch the translation process step by step. And finally, we'll look at the three main flavors of NAT that you'll run into. All right, let's dive into section one, the two key addresses. Getting this idea of a private world versus a public world is absolutely the foundation for understanding everything else about NAT. So think of it like this. On one side, you've got the private world. That's your home, your office network. Everything in there uses what's called an inside local address. Then on the other side, you've got the public world, the huge global internet. And the internet sees your entire network through just one single inside global address. NAT? Well, NAT is the critical bridge that connects those two worlds. So, an inside local address is just the private IP that your router assigns to your laptop or your phone. Here's a great analogy. Think of it like an apartment number inside a huge building. It's totally unique inside that building, right? But the outside world, like the mailman, only knows the building's main street address. And that main street address? Well, that's your inside global address. This is the one single public-facing IP address that your internet provider gives to your router. Every single device inside your home uses this one address to talk to the rest of the world. Okay, on to section 2, the translation process itself. This is where the real magic happens. We're going to see how a private address gets a sort of temporary passport to travel on the public internet, and, this is super important, how it keeps your private network hidden and safe. So, how does this all happen? When your computer wants to go to a website, it sends out a request using its private, inside local address. The problem is, that private address is basically nonsense on the public internet. It's not routable. So, what happens next? It's actually a really elegant three-step dance. First, your device sends out the traffic. Simple enough. Second, your router, the NAT device, does a quick swap. It takes your private IP out and puts its own public IP in. And third, and this is the really clever bit, it jots down a note of that swap in a special logbook called a NAT table. That way, when the response comes back from the internet, it knows exactly which device to send it to. This little table shows the whole trick perfectly. Before NAT, the source IP is your device's private address, right? But look at what happens after NAT. The source IP is now your router's public address. And notice what didn't change. The destination IP. The packet still knows exactly where it's going, it just has a new return address. All right, let's get to our final section. As it turns out, NAT isn't just a single thing. It's not a one-size-fits-all solution. There are actually a few different blueprints for different needs, and we're going to look at the three big ones. The three main flavors you'll hear about are static NAT, dynamic NAT, and something called port address translation, which most people just call PAT. And they each have a very specific job.
First on the list is static NAT. This one's the simplest. It's a permanent one-to-one mapping. One private IP is always tied to one public IP. It's a dedicated, unchanging link. You'd usually see this used for something like a public web server that needs a consistent, predictable address for people to find it.
Next up, we've got dynamic NAT. Now, instead of a permanent link, the router has a pool of public IP addresses that it can hand out. When a device on the inside needs to get out to the internet, it just borrows an IP from the pool. It's first come, first served. And when the device is done, it returns the IP address to the pool so someone else can use it. And finally, we have PAT, which is also called NAT overload. And this is the one that's a true game changer. This is how you can have dozens of devices all sharing one single public IP address. It works by assigning a different port number to every single conversation. This way, your router can keep track of who's talking to who. It's the type of NAT that pretty much every single home network in the world uses. So, after going through all that, the answer to this question should be pretty clear, right? The unsung hero managing all the traffic in your home is almost certainly PAT. And here's the really cool part. By hiding all your private devices behind that single public address, NAT isn't just solving a connection problem, it's also acting as a basic firewall. It's a simple, powerful tool that gives us the connectivity we need and, at the same time, a layer of security we often take for granted.